Great. So it's officially 12 o'clock here on the East Coast. I'm actually dialing in from New York City, our new office location. I was in Denver actually for the last 4 years, and transferred now permanently back to New York City. But we'll still be visiting our friends and clients in Denver on a regular basis. Again, thank you so much for everybody that joined today's session. The motivation for today's session was to really highlight some of the unique capabilities that Builder has that allows you to be able to model an integrated concrete, what I sometimes refer to as a concrete box, or the complete concrete structure from podium vertical structures down to the foundation. The objective of my overview today is not to belabor any of the details, but just to inspire you about the different capabilities that we have. You'll see at the end of the session, I'll make reference to the same point again. Spencer, who runs our support team, will be contacting all attendees of today's webinar and be offering 2 detailed training sessions where he'll kind of spend more step-by-step instructions, kind of going through the detailed workflow. My objective today is really just to highlight what the basic capabilities are. Again, we're going to focus on how to model and design the PT podiums. So first of all, the motivation is, as I'm sure many of you have noticed and observed when you drive around, the podium construction is becoming more and more popular. So as a mixed use residential, sometimes also commercial, you have this has become one of the let's say construction methodologies of choice. Unfortunately, there are very few solutions or options to be able to approach the entire structure as one integrated design approach. I mean, we're working with a couple partners to be able to achieve that, but at this point, you still have, let's say, a two-phase design. But that's really what we're focused on is the lower concrete portion, which I'm going to refer to as the podium. What allows us to do it? Luckily the codes allow us to be able to separate this type of construction into 2 segments. So there's the upper portion and the lower portion, which allows us to treat it as 2 separate structures from an analysis perspective. And that's really one of the key things that's going to be underpinning our approach today. Also, the discussion and the workflow that I'm going to highlight relies on the fact that we are allowed to do a 2-staged analysis. And so here, this is just a section from ASCE 710 that says, we can break the structure into 2 sections. I found an interesting article by Terry Malone in the January 2017 Structure magazine. You can find it online. And he kind of elaborates a little bit further with a focus on timber construction for the upper structure, but kind of lays out nicely the requirements that allow you to kind of take a 2-stage analysis approach, which is really the basis of what we're going to be doing today. So looking at an idealized structure, another part of the underlying assumption that we're going to make today is that the codes say that for the upper structure, depending on what type it is, you can either choose to analyze it using an equivalent lateral force or modal response. But in all cases, we can use the equivalent lateral force approach for the podium. And this is for a single level or, let's say, 2 or 3 level podium. So that's really what we're going to be focusing on, is the equivalent lateral force approach for the podium and concrete structure. This is another, I thought was an interesting diagram that I borrowed from, again, from the article that I referenced. And here it shows the, let's say, the more flexible superstructure for the structure above, and then you have the interface between the more flexible superstructure and the more rigid post-tension podium structure below. The only thing I want to highlight here is that you need to look at the various, response modification coefficients and coefficiencies and redundancy factors for the type of superstructure, and determine when it's appropriate to apply the overstrength factors. In our case, we're not gonna go into those details, but just want to make the audience aware of the fact that that's something that needs to be reviewed and considered for some of the components. So let's start talking about the process. We're going to assume that you've used, some external program, whether it's, RISA, Tekla Structure, or there are a lot of proprietary systems that actually, deliver the base shear and the actual individual shear wall coupling loads for the superstructure. But we're going to go ahead and assume that we have those loads. We're going to apply the cumulative gravity loads to the top of the podium. The lateral loads are going to be entered as up and down couples, representing the the pull up and down forces of the ends of the shear walls. The base shear is, we would typically recommend take the base shear that you have from the upper structure and just apply that as a distributed uniform load on the structure. It doesn't make sense to actually break that individual base shear into, individual line loads or so that are on the slab. It may make more sense to be able to, or you should definitely apply the shear wall forces as couples. And a key thing to notice here, because I know there's sometimes some confusion or questions about which category of load and adapt to use for those superstructure loads. And we recommend that you go ahead and just model those as what we call general loads. And what I mean by that is that if you look at, and I've opened here the user interface for the load case library. So you will see on the top part for this, example project that we're referencing today, that all of the loads, and so I'm going to read through those. So those are, the dead and live loads. So those are self-explanatory. You will also see the EQX and EQY that are listed at the bottom of that list. So in this case, those are the shear wall couples, as well as the base shear from the superstructure would be defined as either EQX or EQY that are applied as general loads on top of the podium slab. We'll get to the loads that you see below, because below you see that to complete this process, we will at some stage come in and apply and define what are called building loads. So these are the, let's say, explicit lateral loads as modeled and handled by ADAPT. But as far as the superstructure load goes, let's keep those as general loads. What does that then actually look like? So we will have come in, and this is just, looking at the EQX shear wall couples, we would have applied those onto the podium. And in this first stage, you see that there's no foundation yet. We're just assuming that this is just the podium by itself, and we're just concentrated on designing the podium. There's one thing that you can do is you can import to streamline the process, and let's say, RISA and some of the other proprietary systems will actually give you, line loads and those point loads in an Excel format. The only caveat with using the Excel import is that you need to know the X and Y coordinates of the loads. So one thing that I know some of my clients have done is they'll just go in and just very quickly just drop in, let's say just a 1 unit load at different locations at the ends of the shear walls, and then just go back into Excel and then just fill in the actual magnitudes, and then use the Excel sheet to re-import, or even use the INP file to re-import those loads. So that's just a quick way to kind of get around knowing what the actual XY coordinates are of the specific load points, and then using Excel or INP to be able to, make it easier to enter those loads so that you're not actually typing in individual values in Builder as opposed to Excel, which is more efficient for that. Once we have our loads defined on the podium, the design of the podium itself is no different than any floor pro analysis and design that you've gone through. So you're just, running it in single level mode, and you're, laying out your post tensioning, laying out your support lines and everything else. One question does come up, and this just crossed my mind. It's not in the slides, but I do think it warrants raising this point. There's always the question of what are the boundary conditions that you should consider. Keep in mind that the boundary conditions, when you're running the program in Floor Pro mode to design the actual podium, it defaults to a rigid roller, which means that the columns and walls below this image that you see here, yes, they can develop a moment at the end, but they are not restrained in the XY horizontal plane. And so what that means is that as you're applying post-tensioning, all of that post-tensioning is allowed to go into the podium deck. None of it is really being lost in the stiffness of the foundation below. So one thing you may want to consider and review in your design approach in your office is, because these podiums tend to be closer to the ground and very close to the, obviously connected to the foundation, you may choose to actually switch the default boundary condition for when you're doing the PT podium design in Floor Pro, switch that to fixed as opposed to the rigid roller. So that's just one piece of advice to think about, and you can actually just do a quick comparison, take one of your models, run the two and see what happens. The big difference will be that some of your post-tensioning from the podium will go into your foundation as opposed to being available as pre-compression in your slab. So the PT design is pretty straightforward. Now let's move things forward. And again, I said, Spencer will be offering the 2 detailed training sessions. My goal is to take you through the entire process in these 30 minutes. So now we're going to move to the foundation, because one of the things that I've heard consistently from our clients out there and just general structural engineers is that if you're just using either Floor Pro or other finite element slab programs, then there's the challenge of how do you take the redistributed loads, right? Because you can't just run an RC slab design, because that doesn't account for the stiffness and redistribution that the post-tensioning offers in your podium. So you're kind of stuck with this challenge of, I have even if I'm using another, finite element program to do the PT design, now I got to take all of those forces, the hyperstatic forces, the redistributed even dead loads, live loads, and bring all of those back through the columns and foundations. This becomes even more complex when you have mezzanine levels or a double level podium, and transfer those forces properly into the vertical component as well as the foundation. So what we can do with Builder is you can extend your model to include your foundation components. So here in that symbolic image, all we've done is just, extended, gone to the base level and have added our foundation components. Those foundation components can be any combination of, just a flat mat, spread footings, so individual spread footings, grade beams, or any other hybrid configuration. One important aspect when you go down this path is to make sure that you're modeling your soil springs as compression only. And because we're going to be including lateral loads, right, the default of Builder is that it's only giving you a soil compression, bulk, let's say modulus of the spring in the Z. You want to make sure that you're also adding those values in the X and Y direction. So let's take a look at what that looks like. So here I've taken that podium Floor Pro slab. We're now looking at the same model, but looking at it from the bottom, so you can see that there are, foundation elements now below. I've highlighted the soil spring, and we're looking at the soil spring user interface, and I've highlighted in yellow compression only. That is key. It is a must to be able to do this process properly. And I'll explain why later. I mean, besides the fact that you do not want your soil to be able to also develop tension. There's one question that I'll address quickly. Somebody's asking is, can you get the PDF? Absolutely. I'll send a follow-on email, and we'll also distribute this PDF just so that you have it as a reference. So key is compression only, and I want you to notice that the KXA and KYA have also non-zero values, right? That's important. Otherwise, you're going to get instability warnings when you try to run the slab in with lateral loads. So now that we've done that, the question is, okay, so we've modeled our foundation. We had started out with loads that represented the superstructure. I talked about how to apply those superstructure loads onto the podium, so we know that those loads can go into the podium. Now we need to calculate the inertial, let's say, seismic forces for the podium concrete box itself. So there we recommend, and now we're switching from the general loads to what we call the building loads. So these are special case load cases that really only invoke themselves when you're running a global analysis. So here you can use the Seismic Load Wizard to automatically calculate the seismic loads for your podium box. So this will calculate the based on the inertial mass and the seismic mass combination that you specify at the bottom left. It'll calculate the forces that will then automatically be applied at the center of mass of the concrete structure and generate those forces for you. In this particular example, the user had selected to do, had given their own base shear, so that's why you see that the load generation is set to user defined, and the user has specified a base shear of 1,629 kips. But the program can also be switched to using one of the ACI codes to auto-generate those loads. So that's how you define the seismic loads. Should you also need to generate wind loads for the actual exposure that you have for the podium levels, then you would go to the Wind Load Wizard. The Wind Load Wizard works very similar to the Seismic Load Wizard, and here you would define, again, building load cases that represent your wind, and you define the exposure, use the different codes to have the program automatically calculate those loads for you. So now, if we step back, we have a set of general building loads that represent the loads of the superstructure. We have the self-weight and loads that we're applying on the podium itself. We have seismic loads that are automatically generated and wind loads. Should you need to have an even more flexible application of loads, you can also use the Lateral Load Wizard. So this can be used to define any wind or seismic load, lateral load type. These all get classified as those building loads, and you see at the bottom left there's an option that says load type wind, and you can also switch it to seismic. The loads, so the only caveat here is if you define a wind load using this, let's say you know what the story force of your wind is and you apply it using this wizard, just keep in mind that the wind, so the base shear at that level or the story force is going to be applied as a uniform distributed load at the center of mass. If you use the Wind Load Wizard, that wind is applied as a line load to the edge of the podium. That's really the only difference between the two. Both can apply eccentricity and other factors that you need. So the question, there's one question that was just asked that said, how would you apply the wind load to the upper wood structure? That's a good question. I'm assuming that the loads that we're applying, remember we started out the session by saying you have those lateral loads that are defined as couples. The default scenario is that the wind that is you have a set of couples for your seismic and for your wind. There are ideas and there are possibilities of, let's say, taking the builder model using kind of fake concrete column elements and, building the actual superstructure above to use Builder to auto-generate those loads. We probably need to do a little bit more work on that just to make sure that it's easy to do, but that is definitely one direction that some of our clients have asked us to explore developments. So we have now covered all the different ways that we can apply lateral loads. Now we're going to be moving into global analysis, right? So far we were just focusing on the podium. So now the question comes up, okay, now I'm transferring loads from, these lateral loads through this concrete mass. Now, depending on your structure and what your office's workflow is, should you need to, let's say, adjust the stiffness, because keep in mind, unlike other structural analysis programs, in ADAPT, when you build a concrete box, it assumes everything is uncracked and it assumes everything is fixed. So you actually get a pretty rigid concrete box right out of the out of your modeling stage. You need to go in and, let's say, introduce releases. So if you don't want your columns to participate in the lateral load resisting, you need to release those, or use the usage that we have, which is quite a unique feature under stiffness modifiers, and adjust the, let's say, the participation or the cracking of walls and columns and beams and slabs as required by your local code to be able to adjust the load path for the lateral loads. The beauty is Builder will keep track of all of those modified load paths, and when it comes to actually applying those loads back to your mat foundation, I'll show you how you can then pick and choose exactly which loads are to be applied based on which load path. So all I'm trying to highlight here is just be aware of the fact that Builder does model very stiff structures because it assumes all concrete is connected. You need to then just think about what you want to release, and you have two ways of doing it: through releases or adjusting modifiers. So now we have our model adjusted. So now we're going to go to run the global analysis, and we're running the global analysis because we now want to take all of those loads, superstructure and the loads that we just talked about defining for our concrete podium, and take those to our foundation and to our walls. So to do that, we're going to switch to running global analysis, and we want to make sure that when we run the global analysis, now remember, we had modeled the soil springs. So one thing that catches people by surprise sometimes is if you just go into that analysis, you get the full structure soil interaction, which is great, but you get a lot more flexibility and distribution of the loads based on the actual, full flexibility of the structure. Plus, it takes longer to analyze. In most cases, I've seen that our clients are satisfied with assuming that the loads are going to be transferred to the foundation based on the assumption of a fixed and rigid foundation to begin with. So what we're doing is we're in the background to run our global analysis, and I'm now switching to where you're looking at the analysis option window when we're in global mode. And what we're doing is, you see here it says, I've highlighted it at the kind of the middle yellow on the bottom left. It says substitute compression springs with fixed supports. So this is really a neat feature, and what this allows you to do is it says solve everything as a global, even though we have soil support, because we're going to design the foundation for this purpose of taking the loads down to the foundation. We want to assume the foundation is rigid. So we're going to go ahead and do that. Once we've done that analysis, and so here's some images of having run this concrete podium box. And now remember, the superstructure that we don't see is not explicitly modeled in Builder, but we've applied all of the couples and the base shear. So you can clearly see the lateral deformation in that structure. So this is giving us our baseline of how we're transferring those loads down to the foundation and into the vertical supports that we want to design. Then So we're kind of done. We're only using the global to really just to distribute the loads and calculate the loads or the forces in our members. Now we're switching gears and we're going to complete the design of the foundation level. So we're going to switch the program to adapt mat mode, and we want to reanalyze this mat mode in single level mode, right? So what we're going to do is now we're going to go back, and it's going to by default force you to run this analysis mode using compression springs again, right? Because it says you're in mat mode. Then the idea of replacing it with fixed supports doesn't make sense. And so we're going to run it in mat with the spring supports. And most importantly, you want to make sure you're selecting the right options to do the load takedown for gravity and lateral loads. So first of all, again, remember when you're reopening, it's the same exact model. All you're doing is you're closing the model. So you save what we've done before, you open it, and when you open it this time, it's going to be in mat mode. And when you're analyzing it in mat mode, what you want to do is you see I want to draw your attention to the top right. On the top right, we want to go ahead and we want to include gravity reactions. So do you see the second blue arrow that's on the right down? That is highlighting, you see where it says all reactions, and that's really key. And that's what you get if you open the model in mat, as opposed to opening it in, let's say, Floor Pro or Edge, because this knows that you're at the base level, and all of your reactions that are coming from your walls and columns are being applied or should be applied to the foundation analysis. And so you see at the top, we have the option to include the lateral reactions as well as our gravity reactions. So that's consideration number one. Consideration number two is you see where I've highlighted here EQX. So what Builder allows you to do is it allows you for this at each stage of analysis, when you're doing load takedown, what you would otherwise potentially be doing, managing these different reactions in spreadsheets. It says, well, here we have a mat that we want to analyze. We know we have loads from above. We might have run tributary. In my example, I had also done a tributary because for my columns, I like to also include the tributary loads. Uncracked is the finite element analysis that we would have run if you had defined different load different usages, where let's say we would have run our seismic with cracking or by excluding the contribution of the columns. That would have been a separate one. And here you can pick and choose for each load case exactly which load path is used to determine its values. And the bottom two options you see for each of these primary reactions, you can also choose which one of the values, the axial values, to envelope. So here we're going to run this by saying we're going to do uncracked, which was our finite element global analysis, and we're going to envelope axial. So that means it's going to envelope the axial from tributary and any other combinations that I have. So this is a pretty powerful way to be able to take kind of and collect and manage all of those other loads that we've been talking so far and apply them to our mat. And if we look at the next step, that's what we would have ended up with. So this is a screenshot of the model after I would have run that analysis. I'm in mat mode, so single level, soil springs are acting, and all the load takedown from the superstructure, including lateral gravity, are all applied to the foundation. So then you would go and complete the design of the foundation in no different way than you would with Floor Pro for the podium. We're laying out our support lines. We're checking with the difference here. You would also check, your maximum soil pressures and other things, but the design process is exactly the same. I had mentioned that, you could also take this 2 steps further to include column and wall design. So here, what you can do then is for each of the columns, you can go to the type manager, specify what the base reinforcement is for the columns. I've taken that exact same model and have now done a quick check. Again, I just kind of made some simple assumptions of column reinforcement before the session and wanted to show that, it clearly highlights those columns with the bigger tributary areas where the initial rebar configuration that I configured is failing. However, that initial rebar configuration meets my requirement for some of the other columns that are shown in green. So here we're just looking at the right side, it's our review, results review, and we are highlighting the column results. So again, you can carry out complete column design, and this column design now includes all of the loads that we had also applied at the podium, plus the redistribution of all of those loads through post-tensioning and the podium level. Then moving to walls, you can take any of your shear walls using the integrated wall design module, go ahead and assign pier labels to them, have the program automatically generate the pier design sections, and this is just an example screenshot of what one of the shear walls wall designs would be. You can get your PM diagrams, do all of your detailed shear wall design as well. So that brings us to just a little over 30 minutes for me to have covered my overview. As I mentioned, I will, based on the request, send a copy of the simple PDF that you can use as a as a way to kind of follow the workflow. And we will also be sending out an email with there will be 2 sessions, I believe, that will highlight on 2 very, very specific aspects of this workflow that I spoke about. Those and expect those to be longer sessions, maybe an hour, hour and a half. These are detailed training sessions that Spencer will run. We'll send out the invites for those sessions for you. In summary, Adapt Builder offers a really unique and an efficient approach to the design of integrated podium-style projects, and it allows you to combine the slab, foundation, column, and wall elements all into one model and workflow. Obviously, what's missing is the ability to also be able to model and analyze and design the superstructure, but we are working with 2 partners at this point, and hopefully within a reasonable time frame, we'll have a solution that allows the industry, you guys, to be able to leverage the power of what Adapt offers on concrete design and the power of what other solutions can do in terms of more general light material construction. So with that, I'll as promised, bring to a formal close the 30-minute session and the overview. What I'll do is I'm gonna turn off my the PowerPoint slide and just go to that model, just so that you can see the model that I was referencing, and highlight some of the components that we talked about in the PowerPoint presentation, while I'm waiting to see if there are any specific questions. And for those of you that are have to leave, thank you again for your attention, and please do reach out to our support teams or to our sales team if you need additional information or are interested in learning more about how this integrated podium design process could help your firm. Again, while I'm waiting for any potential questions, this is the model that we were kind of going through. And what you can see is these are, this is my soil supports. I'm going to turn off our column design status. We're going to go back to, if we want to, under floor design, if you want to see the actual, so these were the support lines that we had in one direction, support lines in the opposite direction. So there, everything is exactly how you would expect it. If I double click on one of these sections, you can see that these are the individual footings that are being designed. There's a question. Okay, so there was a question of whether I'm still talking. Is my audio? If somebody can just respond and just let me know that my audio is still visible, or not visible, but audible. Yes. Okay. So thank you for confirming. So let me just go through and address some of the questions that you have that have been posted already. So there's more questions about distributing this PDF. Yes, I will distribute the PDF. The question is, can our wall designer do L-shaped and C-shaped walls? So let me address that. So I'm going to turn off the analysis. So let me split it into two components. My answer. The analysis that ADAPT does is 100% based on the actual configuration of the wall. So if we go to under walls, and we're looking here, I believe this is my service loads. If we're going and looking at let's look at some of my my actions, right? So the analysis works. So here I'm just turning on my axial. So the analysis works on each individual one. Or let me step back. The analysis works on the composite C or L or any shape. As you might know, ADAPT doesn't restrict how you model your shear walls. However, to give you a specific answer for your wall design question, each wall is designed as its own individual panel. However, we do provide a combination kind of diagram, if you will, that kind of shows all of the end zone reinforcement to help with the final detailing. But the design is based on each individual panel. So that was one of the questions. Then there's a question of, is there any guidance on when to do smear loads versus individual loads? That's a good question. I know on this particular project, if I go to the podium level, you will actually see that this under initial design or schematic design phases, the layout of the walls was not clear. So it started out as smear loads, and then as detail became available, they were replaced with individual line loads. I believe in this case, because I still maintain both load sets, I find that in almost all cases, the smear load is actually in governing. I find this is just anecdotal evidence, right, based on this configuration. So I don't think there's any specific guideline. I think it's probably prudent to do both, but I see a lot of people get away with the smear loads as well. Let's move to the next question. Yeah, so there was another, again, there was more questions about when to add smear loads versus the others. I mean, I guess the beauty of this, and here, let me go, because there seems to be quite a bit of questioning around the loading. So here, what we did, and it was a little bit of a pain initially to handle the two, but here you will see there's a let's take our loads. So for example, this is what I want to highlight is the difference between, yes, you see these are specific loads. So can you see that once I have self weight and dead load, so these were the non-smear load, and then I have a repeat of the same exact load combination where I have the nomenclature on this project just happened to be SDL super. So these are the smear loads, and under self-weight and dead load were the individual line loads. So we essentially maintained both sets of loads because they were in the model, and we just repeat each of the load combinations to account for both. So in effect, we're designing for the envelope of that loading combination in this particular example. Okay, so the question was the reduction of live loads. That's I see the question. I don't have a definitive answer for that, unfortunately, but I can see who's answering that question, and maybe I can go ahead and in my response email that I'll send out provide a more detailed response as to how to handle the live load reduction. Okay, so then there's a question of how to model irregular column shapes. So if you go to the I'm going to go to the column design, and I'm going to open up the section designer. So we're going to go ahead and we're going to, let's say, add a new section. So this is going to be an irregular column. What you can do is, instead of rectangular, square, circular, so these are the adapt standard profiles, you can also define a generic section. I realize this isn't the most elegant implementation. However, it does allow you to model any generic geometry through its fundamental mechanical properties, as well as define any generic material. So the material can be concrete, our standard concrete, or it can be some other hybrid material as well. So that addresses that question. Okay, so there's another question about live load reduction. So let me go to, right, so we're in the mat mode. I'm going to go to my analysis, and I'm going to go to execute analysis. And in this case, I see that it's the live load analysis, or the live load reduction, I see is grayed out in this particular instance. And to be honest, I'm not sure why it's grayed out, but there is the opportunity. I know when you're doing the applying the load takedown in the non-mat mode, it does allow you to apply live load reduction for the column values based on different load cases. And so let me just check something. If I go to my loading under load cases, it's possible that some of these, for example, if I take my live load, if I select that that's reducible, right? So that's a criteria to be able to apply live load reduction to a live load. So here I'm going to go ahead, tag that as reducible. We're going to go back to the analysis, under analysis option, and now it's okay. So that was my oversight before. So to answer not the magnitude, but at least to answer the question of procedurally how, you could come in, and when you're applying your loads to the mat, to the lowest level, you would go ahead and apply. You can then classify that load case as reducible, trigger the live load reduction, and then come in and use. We have a couple simple ways that you can essentially apply live load reduction. So that's let's say one way that you can handle that. And I believe that addresses most of the questions to date. What I'm going to do is I'm going to just go to turn on the complete concrete box again. right? So far, if you look at the top right, I was in single level mat mode. You can see the mode that I'm in, where if I move my mouse to the top left corner, you can see that it's in adapt edge. Edge means that it's supporting multi-level analysis. Mat for being the mode that I'm in, that turns on soil support and also gives you more advanced options for applying all reactions when you're doing the load takedown, PTRC, and shop drawing. So it's just switching over to the global model. There's a, okay, perfect. Yeah, so there's a question that's coming up regarding I had talked about, modifying your load path for the transfer of those lateral loads to the, through the concrete structure and then obviously down to the foundation. What I will do, and I realize whenever I'm on these webinars, everything is, my computer runs a little bit slower. So now we're actually in the full mode. You see on the top right, I have my multi-level mode. If we go and look at this from the side, you can now see that this is the full kind of concrete podium that we're modeling. And if I turn on my tendons, these are the tendons that I would have had in my podium. And then we're transferring those loads based on the process that I described down to the foundation. To address the attendee's question about how to define the cracking. So what I'm going to do is I'm going to select one of the shear walls. And if you go to, right, I had mentioned that you can do your actual, let's see, I'm looking the, so we're going to go to the stiffness modifiers. As I mentioned, the default is that everything is uncracked. So what we're going to do is we're going to add a new usage, and I'm going to call this new usage, let's say, for lateral strength, right? I could have one for lateral strength, one for, let's say, service if I'm doing drift control. So I'm going to say lateral strength. So what this allows me to do now is to go in and modify, let's say, the shear and the bending of each of these individually. So now I'm going to close that. I can also select all walls. So I'm going to go to Home, select by type all of my walls. And now all my walls are selected. Obviously, in a real project, not all would be shear walls, but you can follow the process. I would go to Modify Selection. That allows me to modify all of the selected objects. I'm going to select walls. I go to my stiffness, and here under lateral strength, this would allow me to access and modify the stiffness of all of the walls that I've selected. Once that's done, we go back to our, right, we're in global analysis mode. We're going to go to our analysis, execute analysis. And remember, I said that before we did uncrack, I could now run this for my seismic load cases under lateral strength. If I do that, so this would be now, let's say, EQ. So I'm only running those, let's say, my load cases for EQX and EQY, let's say. I would run that under lateral strength. That means that the reactions in the walls and columns will be based on my reduced stiffness. If you remember when we did the mat, I would then go and say, oh, yes, I remember my EQX should really be coming from this lateral strength, not from my uncracked, which I'm using for gravity. So I hope that addresses that question of how to handle the assignment of, cracking for the shear walls. And the question is, I guess there's a follow-on question there. Can this also be done to the podium analysis? Yes, the same stiffness that we just did. If I select my podium slab object, same exact thing applies, lateral strength, I would have been able to go ahead. And so that same usage, which in this case, the usage regime is lateral strength, would apply to any of the components that we have, slabs, beams, columns. Then there's okay, so the question is, can the design be done in Floor Pro or is Edge required? Design is always done in either Floor Pro or in Mat. To be able to do the complete workflow that I've shown you today, and the complete workflow is really the part where you need Edge, and you only need it really for one of the steps, is to do the global analysis. If I want to do the global analysis, I need the Edge license. Otherwise, if I'm just doing the podium by itself, I'm running Floor Pro. If I'm doing the mat, I'm using, or the foundation, I'm using Mat. I hope that answers that question. And why are we doing the global analysis? Because we want to take the complete stiffness of the entire concrete podium box structure into consideration. This is a single level model. We have many of these models that our clients are doing that are 2 levels, and sometimes 2 levels with a partial mezzanine or other level, and that's where really Edge allows you to properly and efficiently bring those lateral loads from the podium down to the foundation. Great. So I believe I've answered all of the questions. I had promised this overall webinar wouldn't go more than 45 minutes. We're at a little over 50 minutes. What I'll do is, again, formally close the Q&A section so that those of you that want to leave can leave, and I'll stick around for another couple minutes just to see if there are any lingering questions. Otherwise, again, thank you so much for your attention and attendance. And again, please do reach out to our support team. We have an amazing support team, and we have very knowledgeable, sales engineers that would be able to help you, address any follow-on questions that you have. And do look out for the 2 detailed training sessions that Spencer will be offering to you guys. Thank you again, and have a great day.